Okay, so let's get on to the real mechanics of heat energy. Rule number 1. Heat energy is indestructible. Once you've got some, you don't get rid of it so easily. The only way to get rid of heat energy is to allow it to flow to a cooler place. That's the only way. And that's how the Earth has been doing it for many tens and hundreds of thousands of years. Sometimes successfully, sometimes not so successfully, as the record of climate change in the fossils shows. So how is it done? Well, heat energy literally tends to want to run downhill. Imagine water cascading off a mountainside. It wants to spread more thinly and become ever more diffuse to get rid of the pressure that's the gravity, the pressure that's driving it away. Temperature is pressure, but temperature alone does not describe the quantity of heat that is gathered into objects and now wants to find a cooler place to migrate to. On this planet, how is that done? It works like this. This is the sunward side of the planet. The sun warms a portion of the planet's surface. There it is. There's the warm portion. And in order to get rid of that heat, the only way the planet can get rid of the heat and not simply get hotter and hotter and hotter is when it turns away to face dark, deep space. That heat will radiate away as infrared light. Good old infrared light. The sort that keeps you warm when you sit in front of a radiator, an electric radiator. That's infrared light. Now fine, except that it is a simple fact known to everybody. I mean, school children can reproduce this experiment. If you put a little too much carbon dioxide in the atmosphere, then the infrared light and the heat cannot escape into the dark of night, into deep space. It's where it wants to go. If you put too much carbon dioxide in the atmosphere, it is a fact that infrared light can no longer escape. I've shown you that the atmosphere is so small, and I think vulnerable and fragile, but it is so small that you have to wonder why people doubt that we humans, with our immense use of fossil energy and the release of so much carbon dioxide into the atmosphere, given that the atmosphere is so small, how could we not change it? But I just want you to keep all those measurements and parameters of our home planet in your mind the next time you hear people raving on about the pros and cons of climate change and what we might do about it. It's really just up to you now.